Hi all, in this video we'll present our second review for this particular project that we are working on. To begin with, this is the block diagram that was proposed initially. We have now improvised it for the working of the circuit according to the solution that was required for the problem. So we have now mounted our ultrasonic sensors on servo motors to sense a wider area rather than a single point. So according to the initial design, we have placed 4 stationary sensors like we see at the 4 ends of the goalpost.
We have now modified this by placing 4 rotating ultrasonic sensors in an alignment in such a way that the entire area of the goalpost is covered in one cycle. All the motors rotate towards the exterior and interior continuously when no object is detected. Another sensor is placed in between of the 4 sensors later, which is connected to the goalie. So at any point of time, when any sensor detects an object, the other sensors that are there on the 4 corners of the goal align themselves accordingly. While the center sensor mounted on the goalkeeper, it remains at the center and only moves when the goalkeeper rotates. Here, the goalkeeper is intended to move only when the object is detected below a fixed perpendicular distance from the load. The goalpost length is 18 cm. The yellow part is the risk zone. That is, if the ball is found in this region, then there are more chances of the goal being scored, which is of length 40 cm and width 16.5 cm. 11 cm is the distance from the goal post till the edge of the risk zone. So the goal post length is 18 cm. The risk zone that we have found as 40 cm in length and 16.5 cm in breadth is the area in which if the ball is found then the goal will be scored. So the 4 sensors, when they detect the ball, we can find the length of the ball from each sensor and the angle that it makes with that point. Using these two parameters, we can find the perpendicular distance of the ball with respect to the goal. If this perpendicular distance is less than 5 or say 4 centimeter that we set as a threshold, then the goal post or the servo motor that has been put to our goalie will move the goalie in that particular direction.
This is the hardware calibration of just 2 motors with 2 sensors, and the distance between the 2 sensors is 18 centimeters. Now in the condition when no object is detected, both the sensors are moving outwards and inwards simultaneously. Now suppose the ball is coming towards the left sensor, there will be 2 cases, either it will go outside the goalpost or between the 2 centimeters. Now if the ball is less than 7 centimeters near the sensor, my second sensor rotates 20 degrees towards the first sensor. So that if the ball now moves towards the second sensor, it will be in a position to detect the distance. And similarly, if it is going towards the center, both the sensors will stop and detect the distance. And now for this setup, if my object passes through the center, none of the sensors will be able to detect it. But for our final presentation, we will mount 4 sensors over the goalpost. And this setup might look clumsy now, but we hope to present it in a much better way with the help of proper mounts when we interface all the sensors together.
They've used the NewPing library and the servo library. The NewPing library has been very helpful as we can change the number of sensors, maximum distance to be detected and the ping interval directly. Here we have created 2 servo objects, servo left and servo right for the 2 motors. We've given a maximum distance of 7 centimeter beyond which the object won't be detected, and the number of sonar sensors used is 2. The echo check loop is to check the calculate the distance of the object if detected. The echo check function is to calculate the distance of the object if detected, and the one sensor cycle is to perform a few operations once the loop has been completed. In the one sensor cycle, we are basically given instructions to our motors to move towards the interior and exterior side, and if an object is not detected, and if an object is detected towards the left side or right side, move the other servos respectively.